In this section, I'm going to focus on one critical message, which is why is it that we say that the future of machine learning is tiny and bright? Specifically, I want to emphasize why we are increasingly seeing this dramatic interest towards making machine learning fit on tiny devices. Since I keep using the word machine learning, let's go back for a quick reminder. Now, machine learning is a subfield in artificial intelligence that's focused on developing algorithms that can learn to solve problems by analyzing data from interesting patterns. In this course, we're going to be looking at a very specific type of machine learning called deep learning, which leverages neural networks and big data and is able to make observations about interesting patterns in the data. Now, machine learning is something here to stay. It's something we're probably already using on a daily basis. For example, when you take a picture on your smartphone, it's more likely that there is machine learning voodoo that's happening so that by the time the picture comes from the sensor to your screen, it's being enhanced. And when you say, okay, Google or Alexa, well, there's a lot of natural language processing going on in order to understand what you're saying, something we already take for granted. And then, of course, there are times when you go on social media and you give a thumbs up or you give a thumbs down. Well, all of that is helping drive our interest and our patterns of behavior on the network. Because these machine learning systems are learning how to give us information that we want to see more of. For example, when I read news, I tend to read a very particular type of news. I'm not that much interested in all kinds of news, but by giving a thumbs up or a thumbs down, we're actually training the system in order to help them serve us better. Now, these are great applications, right? There are many subclasses of machine learning. Take, for example, image classification. Being able to tell whether the picture here has got a cat or a dog. Well, there's a cat and a bunch of pixels are being fed. And ultimately, this machine learning network says, hey, it's a cat. Sometimes it might look at the same exact picture and say it's a dog, which is incorrect. So machine learning systems are stochastic in nature so that they're not always guaranteed to be correct every time. Then take applications such as object detection. Given an image, an object detector will be able to say that it's actually an orange versus an apple. You'll also be able to precisely locate it in the frame. Or you could even do instance level detections, where for every orange that there is, you'll be able to detect and count the number of objects of each type. And then there is image segmentation, which is very heavily used in autonomous cars, where cars need to know exactly where is the drivable surface and where's the non-drivable surface, where are other vehicles and human beings in the picture. So segmentation is a way of colorizing the entire image into different categories, where all pixels of a certain class are of the same color. For instance, over here, the purple color indicates the sidewalk is all connected together. So that's a non-drivable surface that the car should avoid. If you recall earlier, I was talking about machine translation on smart glasses, where you might have contextual hearing. Well, if you want to do that, you got to take a whole bunch of different words, and then you got to train the machine learning model. And think of that now as a machine learning black box. It's able to make predictions on a particular language, and then you're able to do natural language processing with it. Now, all these capabilities require a remarkable amount of horsepower, a huge amount of computing capabilities. So what companies are doing, they're taking all these computers and jam-packing them into data centers that are all dedicated to provide machine learning capabilities today. So if you ever see a big cement block about the size of a football field that's chugging around the clock, well, that's probably a data center. Now, what's really interesting is that in order to be able to provide that capability, companies such as Google are building TPUs or tensor processing units, or companies like NVIDIA are building GPUs or general purpose graphic processing units. Both of these kind of computing systems are capable of running machine learning extremely fast. And that's needed because at the rate you and I are using machine learning services, when we give a thumbs up or a thumbs down, for instance, there's a remarkable amount of energy that is being used. So people are having to build custom hardware systems in order to support all of the demanding needs of machine learning applications. But building those heavy-duty computing processors, packing them into huge rack systems, and then assembling them into giant data centers, well, big is not always better. I'll tell you why. When you have a big data center like this, you can't have interactivity. You can't carry a big data center in your pocket so that you can take a picture, right? Well, because when you take a picture, what do you want? You want the system to be able to quickly respond back to you. But by the time you take the picture, let's say it has to go to some other computer somewhere else, well, that's going to be slow. But imagine being able to put all of that computing capability inside of your pocket on your phone, right? Why? Because if you can do that, you can enable a variety of different applications that are much more responsive and interactive. Like, for example, when you say, okay, Google, the machine can immediately wake up and you can schedule a calendar appointment or something. Or you might be able to do things like query processing, like asking, hey, where in this text is something interesting that I'm looking for? Now, if you compare large computing systems to a little device, what are the main differences? If I pack a whole bunch of these big computers into a big cement block, well, there's a lot of power we are consuming, right? Gigawatts of power. And if I'm looking at a smartphone, well, there's very low power because it's a small little battery-based device. Now, if you look in terms of bandwidth, the amount of data that the data center can crunch, well, that's a lot of data that you can crunch because all these machines are packed close to one another. As long as the data is nearby, you can move things really fast and do a lot of high performance computing. But if I'm on a smartphone, I don't have much guarantee about the bandwidth. Is it 1 bar? Is it 2 bars? Sometimes no bars, right? The ability to move data off your phone or into your phone depends on your connectivity, right? Many times you have poor network connections. Well, where you are like, why is this not loading? Let me refresh this web page. Or for instance, sometimes you might have a great connectivity and sometimes you don't, right? Well, there's no guarantee about what connectivity in the phone looks like. Or think about the use case, for instance, where you don't want to upload and download a lot of data because it costs you money. So bandwidth, the amount of data that you move and how quickly you can move it, is a critical concern. You want typically a smartphone to have low bandwidth, but be responsive. So accessing a data center has a very high latency because it's far away. Versus if you do machine learning right on the phone, well, it's right in my hand. So I can do it much faster than moving all these bits over to the data center and bringing them right back. But of course, if I have machine learning running on my phone all the time, well, what happens to your phone? How many times have you plug your phone into a charger, more than once in a day? And if the phone is constantly running something that is very demanding from the computing system, well, it's going to drain out of the battery. Now, this is where things get really interesting because we want to move from data centers to smartphones and then to smaller devices. But the reason we want to move is that because there's a lot of interactivity and a lot of interesting real-time kind of behavioral patterns that we want to exercise with machine learning, where we can get more as we make these devices completely pervasive in our lives. So we need to figure out what processing should be done locally to maintain responsiveness and what processing should be shipped to the data center for complex inference. And we want all of these devices to be intelligent because then there's a lot of information and then they can sense and gather things so they can help us. Certainly, we have to be careful about that. We'll talk about the risks and ethics of machine learning a little bit later. So we want low bandwidth, low latency, and low power, along with fast responsiveness and high accuracy for processing images, speech, and other sensor data. Everyday objects such as smartwatches, electronic toothbrushes too, thermostats, wireless earphones, parking meters now have elements of machine learning at the edge by stream processing right on the device to provide real-time inference. Well, that's TinyML today. That's why people are so excited about TinyML, where more complex machine learning models can move this amazing capability from some big computation cloud to you and I, so that we can have a really rich experience right on our devices, being able to respond and interact with them in real time. Now the question comes, where's the big data element? Machine learning needs a lot of data. Well, where's all this data going to come from? Big companies like Google, Facebook, Amazon, have millions and even billions of users that are feeding this data all up to them. So yes, there's going to be big data, in and out, big data out also from the audience. The genie of machine learning, sprinkled with some dust on this big data, and out comes a neural network. This black box, is ready to make predictions. Well, when we go into small devices, where's the big data? That's a really good question, and I'll blow your mind right now. If you look at the amount of data that's actually accessible at the endpoint, like your watch or your toothbrush or that phone, well, there's an insane amount of data because there's so many sensors that are out there at these endpoint devices. The 5 quintillion bytes of data produced every day by IoT devices today, and less than 1% of that data in these devices that we have today is actually being analyzed or used. And if you think that today machine learning looks amazing, well, imagine that what machine learning is going to do and look if you analyze that 99% of that data, and that's just not being used today. Can you imagine how different the world we would be living in? Well, that's what TinyML is all about. That's why we say the future of machine learning is tiny and it's bright. By being tiny, you can make it ubiquitous. You can have it in every single endpoint device around you. Think about it. I want to give you a little piece of homework now. Sit down for a moment and just look around your room. Find a device and think about what it would mean if this particular device was intelligent. What if another device was intelligent? What if another device was intelligent around you? Can you imagine how not only is it making an individual device interesting, but maybe now these intelligent devices might actually collectively be able to do something that each other were not able to do individually. The possibilities are endless, and that's why the future of machine learning is tiny and bright. With that, I want to leave you with the key nugget that there are many diverse applications of machine learning already in the real world, and it's increasingly moving from being up in the cloud to where the big data centers are, to the endpoint where you and I are physically interacting with these devices. And these endpoints, there are many, many around us. Now, even though we have this amazing opportunity, I look forward to going a little bit more deeper now into the next set of lectures, specifically focusing on the technical challenges that are about to arise. So I'll see you in the next video.